we place the classical histogram, so the measure of the gene expression, and we see that, for instance, I just show you this part. So the cells that overexpress 1.1, which are up there in red, the legend, you see levels of fatty acid synthase, boom, down. Lipoprotein lipase, which metabolize lipid particles, down. SCD1, this is stearoyl CoA desaturase 1. This transforms stearate, which is an important lipid, into olate. So it's olate accumulates in the cells. So again, the gene is down. So by this kind of output, we can see which genes are regulated. So this is the last part. Another conclusion that we found is that macro H2A1, that both isoforms are upregulated in steatosis and also in patients, in cancer patients, but 1.1 protects hepatocytes from lipid accumulation, not the 1.2. So this is an indication that the histone can alter somehow gene expression patterns which are involved in lipid metabolism. So what we're doing now, we are trying really to understand more how this occurs. So we worked so far in hepatoma cell lines, but you can work also in primary hepatocytes, which is more relevant. And we are trying to do more sophisticated things like proteomics or chip sequencing. So we're expanding on this. And also we have some mice models which not only are knockout, but mice models that overexpress the protein. So transgenic mice. So we have also this, and we are working on this. Also, yes, basically, since I told you that the gene undergo alternative splicing, so there are two isoforms. So we created the mouse model. It took me 5 years to create this. That you can splice alternatively one isoform or the other. It's an alternative knockout model. So I showed you before the total knockout. Like this, we can have a conditional knockout model. So you know the technology behind this. So it's the Kryllox technology. So if you have a mouse where your gene of interest is flanked by sequences which are called LOXP, and you breed with a mouse which instead carries an enzyme which is called the Cre recombinase. In the offspring, the Cre recombinase is going to cut out the gene because it recognizes the sequence LOXP, and so you have a conditional knockout. Conditional because you have to breed the mice. If you don't breed the mice, the gene is there. So you can do it at also several, a different stage of development. Okay, I will skip this, but we created already these mice that are alive. So it's we can recognize the mice because they have a different fur color. And so in this moment we're in the process of treat the mice with the high-fat diet or try to induce cancer in these mice. Mice that don't have one isoform of the histone or the other. So this is, of course, it's interesting in my little project of the histone, but it's revolutionary because splicing occurs in basically 70% of the protein. You are interested in many protein, in your particular protein, but your protein is affected by alternative splicing. Insulin is spliced, IGF is spliced, thrombin is spliced, like all important proteins are spliced. But when people study this using mice, they had to delete the whole gene. It's not possible to study splicing in vivo. Or it is possible, but it's you can study only one isoform at a time. Instead, this mice will allow us to jiggle with the two isoforms, so to splice out one or the other. Okay, that's all to tell you today. And so I work very closely with the team in Italy, where I hold a position as well. Valerio Pacienza is my partner over there. And then for the mice, I thank Laura Tatangelo, and for the complicated graph of bioinformatics with the balls and the traits, Tommaso Mazza. For the histology, I do them in Italy, Francesco Cappello. The knockout mice that I showed you, the knockout mice are from John Persson in the States, and also from Martin Hofker in Holland. And the people working with me are Michela Borghesan, which is a postgraduate student, Fariba Shefdar, which is a PhD student, and Chiara Montella, who is a postdoc. And thank you very much. I know maybe this is agriculture university. This is very molecular, a bit heavy. But if you don't understand something, just ask him. Yes. Yes. Yes.